Alright, solving a system by graphing. So you can see here I have a system, and in this system I have two variables and two equations, which means I can try and solve the system. And specifically here I want to solve it by graphing. So what that means is you need to graph both of these system lines, and you are looking for the intersection point. So when we're solving a system, one of the things that we have to remember is we have to remember that the intersection means one solution, parallel means no solution, and same line or identical lines means infinite. So one of the things you have to do when you are solving a system is not only are you looking for the answer, but you also have to classify what that answer was. Was it a one solution, no solution, or infinitely many? So the easiest thing to do is to graph this. Now you can graph however you choose. There are many, many ways to do it. My personal favorite way is to use slope-intercept form. So as a refresher, slope-intercept form means y equals mx plus b. And the reason why I like to graph using this form is because it is the fastest way to point out if I have parallel lines or the same line. So I am going to rearrange each of these equations on their own to be in slope-intercept form so that I can graph them here on my plot and see if I can figure out what the answer is. So I'm going to look at this first line. So I have 3x minus the 2y plus 2 equals 0. So I have to move everything except for the y over to one side of the equation. So here we go. We've got the negative 2y is equal to negative 3x minus 2. So y is going to be 3/2 x, because negative over negative will cancel. And then again I'm going to have plus 1. So my first equation is going to be found here by this line. Now I circled it in red, so what I'm going to do in my graph is I'm going to go ahead and graph that using the red color so that you can see. Now if you're somebody who does not care to use color, then I highly suggest that you label the line that you graph so that you know which equation went to which line. Now I have to do the same thing with the others. So I have x plus 3y equals 14. So I'm going to go ahead and rearrange that into my same slope-intercept form. So here I've got my 3y is equal to negative x plus 14. So my y is equal to negative 1/3 x plus 14/3. And here is my second line. So the first thing that I want to notice is that these two lines are not the same. Okay, so when I'm talking about my three solution types, they are not the same, so this is not infinite. Now, the next thing to notice about these two lines is they're not parallel. Remember, the definition of parallel says you have to have the same identical slope. In this first one, my slope is 3/2. In my second one is negative 1/3. Those are clearly different, so it's not parallel. Therefore, this automatically means that these are going to intersect, and it's going to give me a one solution system. So what I have to do now is I have to go ahead and graph. And so one of the things that you need to do while graphing is in each of these lines identify your important pieces. So first we have that my slope here is going to be 3/2, and that we have my intercept is going to be at the point 0, 1. So I'm going to come over here and I've got 0, 1 is my intercept point, and I'm going to go up 3, so 1, 2, 3, and I'm going to go over 2, 1, 2. Okay, so again I went up in a positive direction 3, and I'm coming over 2. And now what I'm going to do is I'm going to go ahead and connect those dots, and to make sure that you can really see what's going on, I'm going to go ahead and use my straight edge here. And so there would be my line. And And so now with this, again, like I said, if you are not, say, color coding, then the one thing that you would want to do for sure is you would want to label your line. So this line was the line y equals my 3/2 x plus 1. Okay. Now with the other line, again, I need to do the same thing. So I know that my slope here is going to be -1/3. And I know my intercept is going to be at the point 0, 14/3. Okay. Well, one thing that I can, or that you should make a note of, is what exactly is 14/3. And when you look at it, 14/3 is really the same. So here my 14/3 is the same as 4.67. Okay, repeating. So a little over 4.5. So what we're going to do here is we're going to first go up to 0 and then a little over 4.5, almost 5. So we're going to go 1, 2, 3, 4, a little more than that. So we'll put it maybe right here. And then I have to go down 1 and then +3. So I'm going to go down 1, which puts it right about here. And then I'm going to go over 1, 2, 3, which will put it kind of right about there. So again, in this case, I went down 1, so I went -1, and then here I went over 3. Okay. Again, I'm going to pull out my straight edge one more time. Okay, and for those of you paying attention, yes, this is my, it is a quilting edge, but that's okay, it'll work for what we're doing. And so here, I'm going to go ahead and connect my two lines here. Okay. And so this is my second line. You can see this is the blue line, and then again I would go ahead and label it. So this would be the line y is equal to -1/3 x plus 14/3. Now, when you're looking real close, there is one important piece that we care the most about, and that is going to be the spot where they intersect at each other. And so that, as you can see, occurs right here. And that is the spot that we care about the most. So one of the things that you want to do is we want to look very carefully at where that is going to be located. So here we're over 1, 2, and we are up 1, 2, 3, 4. Okay, so our best guess, okay, so here you would say that your best guess is going to be the point 2, 4. Now you want to know if that's actually the true solution. So you have to check the solution with the system. So to do that says you're going to plug that into your system. So I would come back up here to the original system you have, and I would use that. So here we've got 3x minus 2y plus 2 is equal to 0. I'm telling you that x is 2 and y is 4, so this is going to be 3 times 2 minus 2 times 4 plus 2, and I'm hoping that that's 0. Well, 3 times 2 is 6, plus 2 is 8, minus 8 is 0, so here 0 equals 0. So we would say on this first system it works, but you need to check the other side. So here we have x plus 3y is equal to 14. My x again is 2 plus 3 times 4 is equal to 14. 3 times 4 is 12 plus 2, 14 equals 14, which means that the point, or the true solution, is the point 2, 4, which is a one solution system. Alright, I have one more example for you here just to try and help and solidify the idea of solving by graphing. So again, just like before, we are going to work with y equals mx plus b. So I'm going to rearrange both of these. So I'm going to start, I have 6x equals 4y plus 5. So I'm going to go ahead and rearrange that, get y by itself. So I have 6x minus 5 is equal to a 4y. Divide everything by 4 and I get 6 over 4 x minus 5 over 4 is equal to y. And you always want to make sure you reduce. So 6 over 4 is going to reduce down and become 3/2 x minus that 5 over 4 is equal to y. And this is going to be the first equation that we graph here. And again, we want to be able to identify those important pieces, so we know that my slope is going to be 3/2 and my y-intercept is going to be the point 0, negative 5/4. Okay. Now before we do anything else, we want to go ahead and work with the other line. So if we look at this other line, we have that 6y is equal to a 9x minus 5. So we are going to go ahead and we are going to go ahead and divide everything by 6. So we're going to have that y is equal to 9 over 6x minus 5 over 6. So here this 9 over 6 is going to reduce, so we're going to have y is equal to, divide everything by 3 and we get 3/2 x minus 5 over 6. So here again we're going to use our other different color in order to graph this line, and so we have this one right here. And what we're going to notice with this one is that we have 3/2 is our slope, and the y-intercept here is going to be 0, negative 5 over 6. So in looking at these two lines, one of the things that you should notice is that these two lines, or these two equations here, they have the same slope, but they have a slightly different y-intercept. So what that's going to tell you is that these lines are parallel, okay? So they are going to have no solution. But let's go ahead and see what that looks like. So the first thing that we need to do is we need to graph our first coordinate point. And so I have the point 5/4. So again, I would go ahead and take a look at what actually is 5/4, and it's going to be 1 1/4. So here I'm going to go down 1 1/4, so kind of roughly about there. And then I'm going to go up 3. Okay, so I've got 1, 2, 3, goes right there, and I'm going to go over 2, 1, 2. So I'm roughly about here. So again, pull out your straight edge if you feel like using it, and you can go ahead and connect your dots here. So we're going to go ahead and do just that. And then just like before, if you are not going to color code, you'll want to make sure that you label your lines somehow, either right now during the process or you do it in the end. Now since these two lines appear to be very close to each other, I would do it after I've labeled it, just to make sure that I don't label my line over the other. Okay, and I'll show you what I mean here in a second. So this one, my y-intercept here is at negative 5 over 6, which is a little less than 1. So we're going to come down to almost 1, so it's going to go right here. And then it's going to go up the same 3 over 2. Okay, so we are going to go 1, this is 2, and this is 3. We'll put it right about here, and then over 2, 1, and then 2. So it's going to be sitting kind of right here. So what you should notice about this line, so if I take out my straight edge again and I line these ones up very carefully, what you're going to see here is that these two lines are running parallel to each other. They are never actually crossing on the page. Okay, so here we can go ahead. We can label my blue line, which was y equals 3/2 x minus 5/6, and we can label the red line, which was y equals my 3/2 x minus 5/4. Okay. And so these lines right here are what we called parallel. So parallel lines means we have no solution because there's no intersection. So there are two examples for you, one where we had a solution, one where we did not. Now the only one that is missing is infinite, and again infinite just simply means that your lines rearranged themselves and became identical, and when that happens your lines then lie on top of each other and they cross at every point. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed yourself as much as I did. If you have any other examples that you wish to see or need help with, please send those to me. I'd be happy to work those out. Otherwise, I look forward to seeing you next time.